So welcome everyone to CIVIC, the Software Foundation. We are the kind of the runners of the Hack Oregon project, and so this will be one of our first trainings in the backend development series. So just a brief overview quickly of Hack Oregon. Then, so we basically have four concepts we look at: data repositories. We try to store data on one place, which is AWS Cloud. We have databases in which we structure that data. We build APIs to allow others to access that, and then we build websites or front ends to that to help make that public knowledge accessible to all. So tonight's training, we're going to be working on Docker and how to learn that the Hack Oregon way. So basically, how we use that, how we use Docker in our organization. Everyone. That's Docker. Now you know the whale. We're good. So yeah, that's kind of some of the high-level takeaways here tonight. We hope you all take away. First, we want to talk a little bit about what it takes to run Docker. So some of the dependencies, how to install it on your system. We're going to focus more here tonight on Linux/Mac OS development. With Docker, Windows definitely provides some of its own issues and problems there. So if you don't have Docker, we're going to hope to do some demos and exercises tonight, but we also want to make sure that those are productive here. And so if we start, we're not necessarily going to be able to troubleshoot individual problems on machines if you have some issues, but we can definitely touch base on doing that at a later point. So the first kind of thing we're going to look at is pulling and running a Docker image. So you know how to get it to your machine and how to get it up and working. We're going to be looking at then also running a Django specific Docker project with our Hack Oregon image here. So we'll get to a point of probably where you can spin up just a basic Django app and see the front end website with the rocket on it if you're Django at all. I'll probably also show just an example of a API image running on my own machine, but we don't already have a database and everything to connect to now, so we won't be able to share a set of credentials and stuff, but just to kind of show the next step in that process. As we go through the next couple of trainings in our series, we'll get people to that point where you can run API locally and probably have just a training image database or something that we connect to. And then, yeah, we're going to talk a little bit about Docker security here. Nick, who is going to be the original trainer who is going to be here tonight, is going to show off an app called Trail that I guess helps to work over Django security. So I'll mention that here tonight, but we're not going to get in depth on that, but hopefully maybe cover some basic security issues. And yeah, definitely how we use Docker for development. So let me skip that. So we also have a break here, probably around 7:30 or so. I'll mention too once Pete's saying things are hard for everyone to eat and just take some break. So to dive in then, I guess the first thing we'll want to talk about is a little bit of Docker vocabulary. I think this helps give an overview of like some of the basic concepts of Docker as well. So the first thing you'll kind of hear about is the Docker image. The images, they are basically a package that takes all the dependencies and information you would need to run an application and create a container environment where this application is going to run. So it's going to include things like maybe Python packages that you need, so like the Django package you can include there. Might include also things on the OS level, like your Postgres client. Things that are going to be, you know, anyone spinning up this image and wanting to run your application are going to need. So you try to encapsulate that into your image. Plus, they're also going to include things like deployment and execution configuration. So there'll be ways to say set up your Postgres environmental variables, like your username, maybe secrets, so you won't bake those into an image itself, or get into how to set those in an environmental variable. So this is more of the, you know, the template of what you're going to need to spin up your image. The next thing on top of that, then you also have a container. And the container is the specific instance of that Docker image. So the Docker image is just something that says, hey, this is, if you're going to run something, this is what it looks like. Whereas the container is what, this is your actual application running, and will include all the processes that services there. Along with that, we're also going to have something called a volume, and those offer an actual writable file space that the container can use. If you guys want a container generate, it'll be read-only. It might be able to spin up and write files within the container, but as soon as you stop the container, basically everything you've done since it's first been built will be gone. So say you spin out the application just within the container, you stop it, everything you've done basically been wiped away. So the file system or volume basically gives you that writable file space or storage there that you can then save files to. And there's a way to be able to connect that writable volume space to your actual local file storage. And we'll show how to do that with the Docker Compose file. The last thing we'll say here is also Docker file. And that's going to be the basic text file that contains instructions on how to build the Docker image. So that might tell you something like connect to app directory to download a C package or something using your configuration. It might also tell you to download your Python files or your Git packages from a Python repository. So this will go ahead there and build your image. It starts from maybe a basic image, or you might say something like, pull the Python 3.7 image from Docker, basically. And that would take all the stuff you need to run a Python 3.7 version application and just put that in there and give you a starting point. So you always want to take a certain starting point there and then go from that. So we're showing you here a tackle that we built a basic Docker Hub file for both data science as well as Python or backend development to be able to perform. Any questions on this vocab before we continue? So a little bit about OS requirements here. So yeah, as we mentioned, basically Windows, and I think they're changing things a bit there, but for Windows to do any kind of virtualization, and ultimately containers and Docker is a type of virtualization where you're running a different operating system than the one that's on your computer and separate from your computer's host system on your computer. It generally requires something called hypervisor to run, and that causes some issues when you're trying to run Docker. I'm not going to get into that too deep here. If you're running like an enterprise version of Windows, then you're not going to have the big problems that say home Windows home is. And I believe that they're also moving, especially as they move to cloud services or Azure, they're going to make it easier. But with that Oregon here, unless you're running an enterprise, we might recommend trying to go to Freaky to get a Linux computer or doing a dual boot on Windows. But doing dual boot is going to be outside of our scope on TCU, though there are some people that can definitely one-on-one get some advice on that. We just want to recommend, say, doing that on your working machine or something like that. So definitely profile that with your job. Steven, do you have anything to add there on?
How many people are running Linux currently?
Linux?
Yeah, on their computers. Okay. So about half.
Oh, now.
Inclusive of Mac? Yeah, are you including Mac? Can you run Docker on Mac OS? I think you can.
Yeah, you can.
So yes, yeah.
So the Mac runs on top of a virtualized. It's a virtualized Linux machine.
Yeah.
But it's basically.
If you consider Docker for Mac OS.
What about if you have a computer just a native default?
I mean, you can do that there. I think the issue might run into the man stuff like that.
Yeah, what kind of resources you have. I mean, if you got a pretty good computer, then that's good. If you got a really old one, then probably better to do a different direction.
And, you know, you can do everything, you know, there's a lot you can do. It's just kind of like, at what point do you get to that patient's level of waiting for it to start those big things, at least, you know, when you're starting to spin up a container or something like that, it's taking that to CPU. So, so how many, does anyone not have Docker already on their systems then, or be? Okay. So yeah, in terms of installing there, then I think you would. What do you think you'd be running on?
Probably not.
Probably
And
not.
also,
Okay.
yeah.
Yeah, if you're on Mac there, I would say I think the Docker instructions can probably walk you through that there. So I might not get into that too much here tonight. But yeah, but definitely we will be able to support any questions you have as you walk through the install then. So Kevin, let's talk a little bit more about what is it there. So we mentioned the Dockerfile and the Docker image. So the Dockerfile will be that configuration on your machine, or tell you are the steps to go to configure your container as you need it. Once you create that, then basically you can install or run a Docker container from that image that you build. Actually, let me step back. You'll first build an image from your Docker file. So there'll be kind of a command that in your CLI that's basically Docker build, and you'll tell it what to build. And it will default just to a file named Docker file in your directory. Once you build that image, you can run a container from that image as there, and that's what you'll see your actual application is. And you can pull that image from two places. Either if you just configured it locally and built it locally, you can have a Docker image on your local system, or you can also have pull an image from the Docker Hub there, and that is a cloud repository that Docker is providing. There can be also a private repository, so Amazon provides something called ECR, or Elastic Container Registry. So we use that to host our production images that we have maybe security or other configuration issues that we don't want to expose to public there. So that's one example. You can also have other private repositories. But Docker Hub is a kind of similar to GitHub. You can store your image up in the cloud and then people can pull it down. Docker Hub actually allows for private repositories as well. So yeah, you have your Docker file. From your Docker file, you build an image. And then from the image, you run the image to create your container. Any questions?
Maybe getting ahead of the stack, so there's no idea if I am, but can we see a Docker file?
Yeah, definitely. I think in the next one we cover with the data and I'll show it. Actually not, but let me go ahead here and just pull it up. So here's an example of Docker file. We'll get into our backend one more in more detail. What we can see is some of the basics. So this is the from. So this is where we're pulling this base image, the Python 3.7 image from Docker Hub. If you don't specify anything else here with URLs and names of the default, those generally assume you're Docker Hub as the source of that, if it does not find it on your location. Maintainers, so this is just kind of a tag there to tell you who's responsible for building it. So you may or may not have that. And this is how you set the environmental variable that this, because it's a hen, will be available both in the build stages as well as when you run the Docker image. So we're not going to get into too much what this is doing, just that gives you an idea right now. But at this point, then we're connecting to app its resource directories here and installing some of the OS side doing things like creating a directory here, and then we're also doing if installers or installing our requirements there, and then copying some other files that we need to run it. Then you see at the end, the entry point is what you're doing when you actually run your stub image. So in this case, we're calling another shell file that will actually be a stub script from a startup or Django app. I'll look at that a bit more detail here in a few minutes.
You drop a link to that, what you have open in Slack.
Yeah, I can drop that in now. Where it will also be in the presentation later as a link to. Yeah. So yeah, just before we go a little bit farther, we're going to stop a minute and just kind of talk about, hey, why do we use containers when we have virtual machine and systems there? So basically, a virtual machine has been the system that for quite some time we've used to be able to spread out a individual app and its dependencies from your wider computer. There's a couple reasons to do that. Security is one there. You separate, code into a very specific container or machine there, so it isolates it from the rest of your operating system. Makes it easier to configure variables there, like if you're working on your machine, but then you need to send out your code to a production environment, you can help manage that the configuration you're using locally also is the same as the production environment. So it makes deploying code easier there. It also makes it so that you can maybe instead of having one entire server or machine to do one thing, you can spread out that, because even though that, your one application is only using 25% of the CPU, you can then spread out your machine into running multiple applications under one server there and be more efficient that way. So reduce cost of resources, reduce machines. So the first kind of generation of this type of technology, VirtualBox is an example. People might know Baker Inc. as a way to run virtual machines too, which sits, I believe sits on top of VirtualBox, is that you're basically generating what's called a virtual machine there. You're generating not just, say, your basic dependencies for your app, you're basically recreating the whole operating system and everything that comes with it. So you'll have your app here on the first layer, and then below that you have all your basically your libraries and dependencies for your application. You have your guest operating system, and then you have something called hypervisor, or a way that basically controls running those separate operating systems. And this all sits on top of your infrastructure, whether it be your local laptop, whether it be a server or a cloud. Now, if we move to the container environment there, containers basically work to just isolate the very minimum dependencies you need for your individual application. So basically, instead of running your entire operating system on top of our operating system, you're running your local system, you're running your container engine, and then you're just running the libraries and dependencies you need there. So you're cutting down just kind of a lot of overhead to that. And that makes a lot of these systems easier there, in terms of just when we're talking about resources and CPU capacity. So that's kind of a big thing that containers have work to do. When you think about, something like, especially as we move to cloud services, Google, AWS, you start thinking about things like serverless computing, Lambdas. Most of this is actually made possible in the back end because of containerization. Because you can cut it down, you can boost up the security by isolating the environments, and you can also really cut down the CPU capacity. Other services needed there to run that. So that's been kind of a major change there that has wrapped around a lot of things with development and containerization. Brian, you kind of get a lot of experience there. You got anything to add about the differences?
No, it's primarily shrinking everything down, making it so that you can run a whole bunch for a long time. We went from 20-something servers down to 2 or 3. It's also really nice for failover. When things go wrong, your containers just start up new. And without needing that data layer, without requiring a specific server to run it, it's really easy to avoid downtime.
Thank you. Any questions there on containers versus VMs?
I have a big question. Do containers replace VMs? Can they cohabitate?
I think they can cohabitate there. There are definitely reasons to have virtual environments there. Essentially, I think sometimes you all running them together. Do you have anything to add on that?
No, I think it's right. I think that there's like almost an industry pressure to put everything inside the containers. If virtual machines are wrong, and I say that's not inherently true. So like if you have like applications that are in virtual machines and that's working fine for you, then it may not be worth the overhead of translating it. But since we're starting fairly greenfield and we're in Python, which lends itself well to this kind of container culture, it makes sense for us to stick with containers.
Beyond that, beyond the consistency thing, just like, isn't it just you can deploy it pretty much read on it, so it's a lot more secure. And also, I mean, having the Docker file there means that it's consistent to get it, and also good for supposedly consistent across other. So, unfortunately, not with Windows, but if you load it up on your computer and the same as it's used for that.
Right. The idea of immutability. Immutability?
Yeah. It's also self-documented. Your Docker files tell you exactly how a machine is built and set up. It's not like in the bad old days that you had a server, but the old IT manager ran one command on and had the whole thing working, 8 months ago and didn't write that down. And you start a new server and no one runs that command. The Docker file has everything laid out. So getting that understanding is part of it.
So when I first learned about Docker versus virtual machine, one of the biggest perks that people advertise is that you can spin up the containers much faster than virtual machines. I don't know if that's true, like from people's experience, but like that seems to be one of the things.
Broadly true.
The thing that you're talking about scripting it is possible, because we also already set it up, right? And then you can just get that off the shelf. Yeah, it's with the boot up in particular, it's like the machine's already booted up all the way, and then you just do that last little pickup to get it whatever commands you have, as opposed to starting from cold steel.
Yeah, and of course there's like lots of work and tooling that went into like doing VMs like that. So like Brian mentioned baking, he has an idea of a bigger file, tries to get through that. You can still modify the VM after the fact. There's like the entire world of Puppet and Chef and Salt and Ansible to try to make configuration management problem at least a little more sane. But it's built right into Docker. The immutability aspect is like if you want to change this container, you have to change the Docker file and then restart the container, which is super nice. You get that single directional workflow, really good immutability.
Do you have like a retail use case for the VM, something else?
Yeah, so like some of them it's like giant applications. So like if you are only going to put one container on one server anyway, then you might as well use like EC2. That's going to be VM. There are other cases that are less common, like if you need like root access or something like that, and you may end up just using the VM anyway. There's also some like pretty interesting stuff happening in the new wave VMs. So Amazon announced Firecracker in like November. So if you're deep about this topic, it's worth looking into, but there's super lightweight, quote unquote, micro VMs, which powers all of Lambda. So there's still research going into it. It basically goes into the idea that if you can write a super fast hypervisor, then you can basically get this, like the model on the left, or you get the model on the right without the container in each part. So it's still trying to go for super fast and that kind of thing without that container in itself. But like odds are you want to start with Docker, and then if for whatever reason that's not working for you, then explore a virtual machine solution.
And outside of service software, you'll take personal sheets from my quote there, and like, I need them for a number of workflows.
Yeah.
To run our machine. There you go.
Thank you all. So yeah, this sort of, we showed the Docker file, but this kind of gets you quite a bit more basics there of the different parts of it and some of the commands you see. So basically you'll see different commands that will happen when you're building versus running a certain command or service there. Trying to figure this out a little bit. I mean, so, you know, as we mentioned there, you have the from, and that will pull up a Docker image, or is this the ones that build the different papers? As I said, I inherited some of these slides, so I try to go through most of them there. So this is kind of the basic things you'll see in the Docker image. I'll pause here and say one of the things when you're writing a Docker file, depending on how you write a Docker file and which commands you use, it will decide whether or not to build an intermediate layer versus basically a new layer there. So depending on how you organize your Docker file and which commands you put forward to others there, you can significantly change the amount of like rewriting and time to run the Docker image and build the image, depending on how you configure it. So that's something there that Docker definitely has some better documentation on how to actually build the image. Tonight, we're going to focus more on just kind of how to run and work with them there, then maybe get to that at the end. So yeah, as we said there, one of the big things with Docker, like why we use it, it gets you from that problem of like, hey, I was able to run this in my very specific environment. I forgot which version of, say, Django I was running, or a lot of these things here. We can kind of configure and organize that to both help you be successful, but then help the next person down the line that you know, the deployment engineer or to get your code up into the cloud, you know, help your users actually use your code because they're spending less time debugging issues that you realize once you got to your production environment, there was a weird environmental variable and caching testing, things like this there. So, so yeah, we're going to go ahead here and then maybe jump into a demo here and then maybe depending on when the pizza and stuff arrives, we'll take a break and then come back there. So let's see here. So this was a demo on installing Docker, I guess. I think maybe it sounds like most people have this installed at this point. So let's see here. Now, one thing I can show is how to check your Docker version. So let me put this over. So if I just want to check my Docker version, make sure it's installed and stuff here, I can just run Docker version. And then you get your information about what Docker version is. So if you've installed Docker, you want to make sure it's there and stuff, and you've correctly set up your pathing, that's a good way to do that. Let's go ahead now though. We're going to run a hello world image and just kind of show the process of pulling down the Docker image and then getting it up and working on your computer here. That's just kind of the first pass.
Keep on the hot side of the Thank you.
So before I do that, I'm just going to go ahead here and run a command, see what Docker, like if I'm currently running any Docker services or anything like that, if I have any open images, before I begin this process. So that would be just doctor.ts.pay. And I can see right now I have no containers, images, or anything running. I tried to clear everything out before I came here tonight. So if I want to just say, oh, to Docker, like everything, they give you a hello award where you can just kind of run it and see what happens there. So what I'm going to do here is the most simplest thing is just to do a Docker run command that's going to pull an image. Since I don't have it locally, it's going to pull it right from the Docker hub and then run it there. And that's what we see just happen. So what's happened there is it pulled the Docker hello world, and then because I didn't have it locally, it tried to build it here from the most recent commit of that image. And then it downloaded it. It told me that it was pulling the latest version, and then it went ahead and ran whatever image first, Docker entry point command it had there. So that all happened because this is such a small thing. It happened that quickly there that, yeah. So, and it tells you, it contacted the Docker daemon, which is, the background Docker system. It pulled the image from the Docker hub, it created a container, and then it outputted this to the Docker client. Now, another way you can also run an image if you want to say not just run the command, but get inside of it, and then, basically run terminal commands. You can do a run with these flags, which basically is an interactive terminal. It tells it the image name, and then it tells it what to run, which is bash, so basic terminal. So I can go ahead and do that here now too. Since I don't have the Ubuntu image on my computer right now, it's going to go ahead here and download that. Because it's basically a Ubuntu, Linux system there that took a few seconds longer to get up and working. But as you see now, my command line, instead of being at my username here, I'm at root within my Docker image. So if I did something like ls, see I have a basic Ubuntu file system there, and I'm within that Docker image that I'm running. If I want to exit that and just go back home, then I can go exit, and then I'm back there. And basically, I stop the image over here. Now let's see what happens when I do the Docker. Okay, so you can see there then that basically I have two images. They both exited now, but I now have two images in my system. Now, since I didn't specify names, you get that kind of random naming of your images there as well. Okay. So at this point here, I've gone ahead then and pulled and then ran two images. Let's see, I think I might pause here then if people want to kind of go ahead and do that. Let me go ahead and share my screen again. Then if you want to go ahead and try to pull the Docker. The our Word image, and then also run that into let me know when you've done that, or a couple of minutes. And basically, you can go through all these commands if you want.
It's also worth pointing out that, at least for me, this was a learning curve. Docker files, you can commit those to a private repo, build a Docker image, and someone does not have access to the initial ingredient. I think that's image. So you can have the ingredients be private and the image be public, which is not something that people often do, but you occasionally see. Yeah, the Docker file, which is like the ingredient list, like a copy this, run this, you can make that private, so your ingredient list is fine. But then publish the image itself, and then that exists and people can use that, but they don't necessarily have the ingredient list.
Kind of like giving someone a binary for the source code.
Exactly.
So you could just have the image in your.
I've also worked with developers who like just build virtual machines, using like getting into Docker, interface with Bash and then saving that image as a file. So no Docker file, just set up here.
So this is a very basic how it works. We can see here goes from the splash image, copy that hello directory from basically the root position you're in, and then basically run, oh not directory, but file to root of the Docker image, and you can see here command the hello file is a C file here. And that's responsible for basically what the software. Did anyone run into any issues running then the basic example? Any questions there? So now we're just going to look at another Docker image here, and this one does a little bit more interesting stuff then. So one thing we're going to get pause here is and say, if you create a Docker Hub account and you haven't changed your password in say the last maybe week or so, we would encourage you to do that. There was a breach or issue with Docker automated builds that caused some security problems there. So get the PSA to go ahead and change your password if you have one. So now we're going to go ahead and look at another Docker image that does something a little bit more cool than just bring out to the command line here. It's the 9N cat image. So this is a little lightweight container there, and it can definitely, it provides a little bit more complexity here in terms of how you can run it and in different environments or operating systems. I guess when you do the standard scratch one here, then the folks want to follow along there too, I guess kind of copy that with some picture. That's just kind of another example of a Docker image that can be run there and just kind of pull down, and basically you started this program and are running it there on your terminal, basically just from one command line thing. Now, if we go there, we just kind of look at some of their code here as well, and we can see that basically on this image, they created it so you can run it in two different operating systems. The base Docker container system, or what's called Alpine. Alpine is a very slimmed down version of, I think it's Ubuntu that is basically a bare minimum. And you know, if you're really looking at space, CPU capacity, things of that nature, people generally start with Alpine. With Hackorgan, we do not. We end up starting with a Python-based image rather than images there because starting with the Alpine, basically you have almost nothing in it, and a lot of times you end up having to fill dependencies back in. So if you know, as a volunteer organization with what has been time to manage containers, we've kind of gone to the, hey, let's just kind of include it there or make sure it's not, as long as it's not a security issue and stuff, with kind of more and base image, and we're trying to make our developers successful and not spending a lot of time adding in very basic like packages that you might expect out of an operating system there. So I just want to give you that kind of overview of why we do use the image that we do.
I'll find like maybe 15 seconds faster than the others. And if it takes you 2 days to install packages to get everything right, it takes a long time with 15-second startups to make up for that.
I'll keep people feeling now. I'm not sure if he's here yet or not, but if people are hearing great, I want to make sure that this is because after this, we might start diving into more of the hack-oriented usage and looking at some of our containers there. And Karen, do you want to talk maybe a little bit about the data container details and how that works?
Sure. Can you say a bit about it?
Yeah.
We can do that after the.
Another note about kind of Docker files, from data in particular. Whenever you're pulling or you're rotating images from Docker Hub, you can, that Docker file that you're pulling from is also public. So just because I was curious, I traced back what Python 37 comes from, and it comes from like a series of real pack images and then ultimately it's dev. But if you ever see a from stance on coming from a private registry, you can trace back, look at all the public files. So.
And that's, definitely if you're working on a project or something, but you're like, oh, this image seems cool, that's what you want to do, that's a good practice. You're like, hey, what is it actually installing? And sometimes, that can end up creating a network or something back to your host machine, or it exposes the vulnerabilities into the software you're doing. So that was a big security risk of the Docker and other private hack issue that there that, somebody could go in and basically trigger your image and put in software to expect and have you happen. So yeah, I'll go ahead here and Karen talk a little bit about the Docker image she's created for Hack Oregon data scientists. Then here we have basically the GitHub repo as well as the Docker Hub.
I might have the more direct Docker Hub in backend right now. Don't know if that one.
Well, like
Yeah.
no abstraction.
Yeah.
You found the link.
Yeah.
I just can't post the public link. That's all the time. Right. Yeah, so for this particular image, I've actually made the Docker file available so that people know what used to build the image. I believe, yeah, so on the right-hand side, if you click on the GitHub repo, then you will be able to see the Git repo with all of the build information. So if you go to the build folder, that's where I put the Docker file. So basically, it just uses the continuum and conda as a base image. And then this is an image really more catered towards Python users than our users. There should be like an all version of this image later on, but I haven't got time to do it. So within this Docker image, we install a bunch of dependencies that will be helpful for your data time. For example, pandas data frames. located or plotting interactive visualization. Custom libraries like PyTest, things for generating documentation for Python code, Jupyter for sure, for launching notebooks in case people need it, Matplotlib, which is another visualization library. XLRB is actually a library for connecting to Excel spreadsheets. So if you want to write directly, write your data out as Excel spreadsheet, that library could help you. Other things that could be like helpful would be like stats model or doing statistical types of functions. And then S3SS is for helping us connect to like S3, other libraries are for like documentation purposes. Like Common Mark is for markdown generation. If you want to write markdown from within things with the documentation, you can. And then, of course, cookie cutter is one of the dependencies that we have. The GitHub repo that I'm showing here is actually based off of the cookie cutter template. Yeah, so, and then there's also an alias. In case people want to launch a Jupyter notebook from within the Docker container, then there is a shorthand function called IPYNB. And that will actually launch the notebook at the port 12345. And if you actually use the Docker Compose file for launching this image, so if you go back up one level on this page, so you click on the Docker Compose, then there's like a comment on top showing you how you can run this. So you can just use Docker Compose run, and then it would launch the Docker image with the correct port so that you can actually run the iPhone notebook from within your container, but you can still feed from outside the container at the port 12345. So if you want to expose certain things, like from within the container to outside the container, to let's say you have a Windows machine, but then you're running something within the Linux container, then you want to expose that to your Windows OS, then you can use Docker Compose for you to organize all those exposures. So, for example, Jupyter Notebook will use certain network ports for showing the website, then you would want to specify it. Otherwise, it will just be launched within the container, but you won't be able to access it like on the Windows side. Also, there's one command that I've added, or one dependency that's the volume. Like even the file system will be able to communicate between the external laptop, local machine OS, and the container, so that you can actually read and write files.
Yeah, it kind of goes back to the virtual machine problem, where this one is using a single image, but Compose implies the name that you can compose multiple images. But the idea is you could run a Docker command that mounts that volume and exposes those ports, but then you'd be doing configuration by hand. And then Brian does it slightly differently, and that you do have to talk about how it works for your business for now. So instead, you write all the instructions to a Docker Compose file, and you run one command, and you get consistent changes.
Yeah, that was definitely something we're transition into there is the usage of Docker Compose. Yeah, because generally, especially for development, we'll provide Compose files that just help people get up and looking quicker. The port switch one definitely thing there that helps you specify that. That also helps you keep out conflict. Like if you're running something locally on your Postgres versus in the Docker container, they're both on 5.32. Which one are you listening to? So that helps you kind of remap ports there.
We use it where your containers basically act like a bunch of computers on the network. And so if you want to bring up Django, you have to wait for Postgres and Redis to come up. you can make sure to put in dependencies and compose things, so students can compose up, and then it brings up all the Docker images with the right settings and the right order, gets them all on their own network, inside your computer, not your general network, gets them all talking to one another, and then you can poke holes directly into that.
So this is an example of a Docker compose file we used last year for our Docker development. And this shows you an example of where we have two different containers that were composing through a single file. And as Ryan mentioned, we could then network so they're talking together here. So we have a development database container where we're building in the Docker context. So telling it, because we had two Docker files within the same directory, we're telling it which Docker file to start up the database from versus, say, the API. And then we're telling it how to name the image and what environmental variables to pass into it, as well as remapping the port number from a 5432 to 5439 there. And then we also have our API development. And this is what I'm talking about there is dependent on. So what we tell you is that this API development won't start up until we actually have the database. So it's going to fail.
And it's a little bit like swallowing the watermelon, where you kind of have to know, like, you have to know command line commands, you have to know the different services that you're doing. You also have to know what counts as like Docker file syntax and Docker compose syntax. Once you get your head around it all, it makes a lot of sense. It's really nice. But just looking at one of these files, it can be a little overwhelming, knowing that some of that's environment variables, some of those are commands that are run, some of that is specific YAML syntax.
But so like that first one, is it mapping from 5439 to 5432?
Yes.
So locally, you're in the container, it's on the 5432, but outside it's 5439, is that what it is?
Yes.
Yeah.
Definitely there, and then you have the volume here again, this is taking, but wherever you are in the root directory, it's going to take what all of the code you have in your root directory, and within your container, put it into your directory code. Basically what you're doing there.
I'll say that we just walked on the piece.
Yeah, so this is probably a good time there to take a real pizza is that we're going to pause the recording here, and we'll take maybe 10 to 15 minute break and come back then. Or we dive into maybe the back end here, some more of the conflict as we have time.